So what we're going to look at here is organizing two categorical variables. So with the examples with eye color, that's where we just collected one categorical variable. But now this is where we collect two. So it's organized in something called a contingency table, or it's sometimes called a two-way table. And it's where we have these two characteristics. So researchers took 72 chronic users of cocaine and separated them into three treatment groups. One group had desipramine, one group had lithium, and the other group had a placebo. And they took information about whether or not they relapsed. So the idea being that we have these 10 people right here, and we know two characteristics about them. They were in the desipramine group, and they relapsed. And then these 14 people here who were in the desipramine group didn't have a relapse. So within this group, we get two pieces of information instead of just one. So that's where the two categorical variables come through. So organizing our data into a contingency table, we can calculate probabilities like we were talking about before, but we can get more specific in terms of describing more because we have more information. So there's going to be many things we look at with these contingency tables, but we're going to focus on here are just marginal probabilities and joint probabilities. So marginal probabilities, for example, if we select a participant at random, what's the probability that they had a relapse? So we're looking for the probability of relapse. So for our numerator, we want the people that relapsed. So with that, for relapse, there's nothing specific about which treatment group they were in. It's just that they relapsed. So we want to take this total 48 out of all 72 participants. And that should give us a 0.6667 when we round that. So this tells us that 66.67% of participants relapsed. So what we want to notice here is, and that's why it's called a marginal probability, here they're just looking for the probability of a single variable. All they're talking about is that they relapse. So which puts us in this whole column here. So we use this value. And it's because we're using the values in the margins, like this 48 and 24 is considered the margins, and then these totals here are also considered the margin. And it's the idea that they didn't give us information about two things, just one, that throws us into the margins. So when they ask for what is the probability that a participant did not have a relapse, we look at the probability of no relapse. And with that, in our numerator, we want the number of people that did not relapse. So again, no information about the specific drug treatment. We're just in that total of 24 there in the margins, out of all 72, which will be a 0.3333. So 33.33% of participants did not relapse. So, key is here, these are the marginal probabilities because we use the number in the margins, and it's because we're only looking at a single variable. So that's one way to get probabilities from this contingency table. Other probabilities we can get are joint probabilities, and this is where we combine two variables. So here we're looking at what is the probability that a participant took desipramine and had a relapse. So if we look at our table here and want to find everyone that was taking desipramine and had a relapse, with and we want to think of that as very exclusive, like it has to be both. So taking desipramine and relapse, that's going to throw us into the middle of the chart here. And here we're going to have these probabilities because this is where we see the overlaps of two characteristics. So for this calculation, probability of desipramine and relapse, if we make our function In the numerator, we want all of those people that were on desipramine and that had relapse. That's those 10 people out of all 72. And for all of these cases, our denominator is 72, because in the question it says, what's the probability a participant? What's the probability a participant? So they're not specifying what kind of participant, it's just out of all of them. So that's making our denominator 72 each time. So 10 out of 72 will be a 0.1389. So this tells us that 13.89% of participants took desipramine and relapsed. And for another example, what's the probability that a participant had the placebo and relapsed? So taking the placebo and relapse, if we go to our table up above, we want to look for the intersection of the two. So placebo and relapse, it's going to land us with those 20 right there. So probability of placebo and relapse, for our numerator, we want those 20 people. And again, out of all 72, because we're looking at all of the participants. And this is going to be a 0.2778. So 27.78% of participants had the placebo and relapsed. So these are called our joint probabilities, and we can often think of these as intersections. When we have a table like this and we're looking for the and scenarios, you want to look for the intersection within the table. And it's coming from that word and between the values. Since we use that and that, same thing there, that's what's creating the joint probability.